Okay, hello, my dear students, my beloved students. How are you? Hope all of you are fine and safe. Yeah, so now we have to start our life in normal way. So welcome to our digital system design course. Okay, the course title of digital system design is CSE 4621. So what is digital system? You can understand nowadays everything surrounding us, everything is our digital system, like this PowerPointer presenter, okay, the cell phone I'm using for video, the computer, everything is a digital part of digital system, okay. Even the fan is sounding, so for controlling this fan we will also use the remote controller. That is a digital system. Okay, we are using remote controller for television, uh, DVD player, even for kids we are using some car, okay, RC car, RC plane, everything is about digital system, okay. Before few days back, okay, before few time, everything was electronics, like everything could be controlled by electronic circuit. We could control by electronic circuit. But nowadays, everything become digital system. That means what? Okay, inside the digital system, inside the analog system or the circuit board, okay, the microchip was entered, the microprocessor was entered, which is called a microcontroller or controller chip, you can say like this. Okay, this kind of very small processing unit, having very small processing unit and having very small memory, okay, can perform very limited number of tasks. These kind of chips arrived, okay, this kind of processing unit arrived in this current world, and these kind of chips are using in everywhere. These are very cheap also, okay, very cheap, okay, from 20 taka to 2000 taka, which is really cheap, okay. Like I bought this thing only 1000 taka as I can remember. So you can see there is a laser pointer, there are number of buttons, there is a microprocessor inside here, there is another communication medium, everything is in only 1000 taka, but the production cost was maybe 200 taka, okay. So since everything is becoming very cheap, everything will become digital system. So that's why this course is so important, like how the system is, how the world is changing, okay, how we will co-op with this world. Are we ready for that kind of world? Okay, to get ourselves ready, what to do, okay, what kind of preparation we should have. Whoever we are CSE student, we are triple student, we are, how to say, natural sciences students, but everything will become digital. Like I have seen some watch that is measuring my health condition, okay, you know, this kind of watch is very popular in the current world. So that kind of different type of gadgets are coming every day, every time. My son is playing the PlayStation, this kind of even playing module, okay, or gaming module also came with the digital system. So that's why this is so important. What is the difference between normal computer system to digital system is you have to interface the hardware with the software. Okay, we have the software inside the computer, but we need to integrate the hardware with this software. That is the main critical part. Okay, and for information, nowadays we call it firmware. Okay, the demand of this firmware programmer is raising very high because all the devices are using this kind of firmware. Okay, like one brain computer interfacing device to Myo device that can sense your muscle movement. Okay, this kind of the watch, everything needs some firmware. So firmware developer is also another very big requirement. Okay, so one very important part of this course, of this digital system design course, is to develop a digital system, implement it, test it, and experiment with it. Okay, so this is one of the very critical issue of this course. So guys, students, get ready to develop some hardware in your home, try to interface with your computer, and then you have to make a presentation on it. Okay, you have to make a demonstration on it. Okay, so let us start our session. So once again, the course name is Digital System Design. It's summer semester. I am taking 3 sections, and my name is Khalilur Rahman. I am Associate Professor of CSC Department of Brack University. Okay, that's all. This is my personal information, how you can reach me. So one is my email address. You can reach me by email. You can email me. I check regularly. Okay, after every some hours or every some minutes. Okay, I check my email, except the class time. And the second thing is my cell phone. I don't recommend to call me directly. You can text me, then maybe I can respond you. Then you can call me, or you can, if you have really need, you can call me on my phone or WhatsApp. Okay. I have also some social media network, but I don't recommend my student to contact with me by using that kind of social media. Okay. So this is the course outline. You can see at the beginning we are going to cover review of digital logic components and analog logic components. Like, you know, everything in digital system, whatever we are using is analog system. Like we are using, what is the main part of a microprocessor? What? Logic gates. Okay. And then what? Transistors. What is transistor? It's an analog logic. Okay. The inside of the transistor is happening the analog electronics. Like there are free electron, we can control that free electron by using base current. Okay, so the gate is opening, the gate is closing. This is the part of analog electronics. Okay, so we are going to review the analog electronics. Then we are going to review the digital logic design that you studied in digital logic design course. Okay, we'll just have to have some review, because in this section, in this course, maybe we are going to integrate something. So for integration, you need that kind of knowledge. Okay, so this is another important thing we are going to cover. Like we are going to show you how all of our courses are integrated together, like operating system, like even high level language, low level language. We learn a number of programming language, even how AI or vision is integrated with the digital system. Okay, so that's why we need to review the digital logic components and analog electronics, and then introduction to digital system design. Okay, we are going to discuss what kind of digital system are currently available around us. Then we are going to introduce IoT device, Internet of Things. You know, Internet of Things is very, very hot topic in this current world. So yes, this is also part of digital system. Okay, so we are going to introduce you some features of IoT, and then we are going to show you how to develop a 4-bit computer. Okay, we are going to show you how to design, how to build, how to integrate ALU with CU, with memory, and with the secondary storage. So and also with the output device. So we are going to show you how 4-bit computer can work, or how a 4-bit computer can be built. Okay, that is the thing we're going to cover. Okay, and then we are going to discuss with you some hardware definition language like HDL and some other low-level languages. And then we are going to review the interfacing, and after that, this is very important, system development methodology. Like whenever you will go, you will work in some company, some industry, or you will develop some project proposal for doing all these things. You need to know what is the methodology of digital system development. Okay, so hardware system development methodology we are going to discuss with you in this semester. Okay, and then the documentation and publication. This is very important. Okay, we can build this and that. We are building a number of projects, but if you don't have any documentation, it will get lost. Okay, so you have to show this thing to the world. You have to show this thing to the customer. Okay, so that's why we need documentation. Okay, so we are going to show you how can we make a technical paper, and then what should be the how we can prepare a good presentation, and also how can we build a very good video presentation or demonstration for this system. Okay, and then some case studies, like we have some signature projects in BRAC University, like Chandrabod project, like BRAC Onmesha project, like BRAC Duburi project, also Mongoltori project. So we are going to have some case study, because all these are very, very critical, extensive digital system. Okay, so we are going to discuss with you about all these systems. So this is the course outline. This is the tentative mass distribution. Since I don't know how this situation will continue, so maybe in this semester will be continued on online course. So quiz will have very, very less emphasis, only 10% for the quiz and 15% for assignment. For information, I would recommend you to prepare the assignment by handwritten. I don't accept computer generated assignment. Okay, you have to write that assignment, you have to take the pictures, then you have to upload to the drive. I'll provide you. Okay, and then the lab marks and projects. We are still discussing how can we prepare the lab or how can we get the demonstration from you about the project. So for lab and project, 25% marks. If you can make very excellent project, or if you want, I will discuss with you again later about it, but if you want, I can give you more marks on project. But in that case, I don't know, in this situation you have to work by your own in at your home. But if you can go out, if you can work with a team, maybe I can give you more marks on projects. Okay, and then midterm 20% and final 30%. So this is 100% marks. Anyway, this can be changed. So that's all for our introductory lecture. Okay, I'm going to continue this lecture after some time. Okay, in another slide, in another presentation.